Future value of a single amount of money. If we invest $100 today and it earns 10% interest in 1 year, after 1 year the total value of our money will be the original $100 we invested plus the $10 in interest that we earned. We refer to the total of $110, which occurs 1 year from today, as a future value. A couple of things to note about the type of interest. If you make an investment, let's say the prior example where we invested $100, and the interest rate that we're given is 10%. If you simply receive $10 in interest, or the same 10% every year, we call that simple interest. Compound interest means something different than simple interest. What you would do is you would earn 10% interest the first year. The second year, you would actually earn interest on the total balance, which would include the interest that was paid in the prior time period. And we refer to that as compounding. Here is an example of calculating a future value of a single amount of money based on compound interest involving more than one time period. So here we invested $100 at 10% interest, and we leave the money alone for 2 years. You'll notice that after the first year we have $110 total. That includes the first $100 we invested plus the $10 in interest that we earned. What we notice after year 1 is that the $110 total balance, which includes the interest and the original $100 investment, becomes the new basis for calculating interest in year 2. So you notice that interest in year 2 is $11 based on a total of $110. It's not $10. So when you add the $11, now we have a final future value after 2 years of $121. This is called compounding to get a future value of a single amount. Some definitions that we need to be aware of, and these are used throughout all of the time value money equations, are present value is usually, the notation is usually PV, and that refers to the amount of money today or to the amount of money at the beginning of the time period in question. So in this example, it would refer to the $100 we've invested. Number of time periods is usually referred to with the letter N or the letter T. Sometimes it's called rate, or excuse me, sometimes it's called period. Sometimes it's called N per, NPER. Rate, the next one, usually refers to interest rate, usually identified with a letter I or a letter R. Future value is usually shown as the letters FV, and that one's pretty consistent. Usually FV and PV are very consistent regardless of which technology or textbook you're using. The others tend to have different notations. You just need to be aware of what they refer to. So there's a shortcut to calculating future value. Assume that you have many time periods involved. It becomes a little bit problematic to calculate the ending value for each year and then start over in calculating the next year by hand. So algebraically, you can shorten the entire thing using the expression that's here on the screen. We would say that the future value is equal to the present value times 1 plus the rate of interest raised to the number of time periods. And in this example, if you plug in the prior variables that we used in the other when we looked at this earlier, you'll see that you wind up taking the $100 present value times 1.1 and the 0.1 equaling the 10% interest raised to the number 2, which would be the number of time periods, and when you solve that you get 121 future value. Another shortcut to calculating future values that involve multiple time periods is to use a financial calculator. Most financial calculators have already got the algebraic expression built in. You simply need to enter the variables which you know and solve for the one which you don't, which in this case would be future value. Every financial calculator is different. You'll need to refer to your user manual to make sure you understand how to input all the variables, because each calculator does it in a slightly different way. In a spreadsheet, we use something called the future value function, although there are other ways to do this in a spreadsheet. Theoretically, in a spreadsheet, you could build a table that would manually calculate future value and just have the table expand to include the number of rows that match the number of time periods. You could also program the algebraic expression for future value into the spreadsheet. What we're going to use here is the future value function, which is already built into the spreadsheet, and we'll demonstrate how that's used here. So we have a spreadsheet here, and you'll see that we have identified a present value as $100. We've identified a rate of interest as 10%, and we've identified the number of periods of time here, which would, in this case is the number of years, is 2. And what we're going to do is solve this using something called the future value function. So I'm going to bring up the list of functions that are available in Excel, and I'm going to search for future value, or FV, which is the name of the function, and that comes up at the top of my list here, so I'll go ahead and select it. You'll see that it's asking me for different variables. So the rate of interest is located here in this cell, E3. I'll just go ahead and select it. Number of time periods is located here in E4. And we're going to ignore this payment field because we don't have anything that fits that right now. And present value I'm going to identify as being in this cell right here, E2. One of the things that you'll notice about time value of money calculations in either calculators or spreadsheets is that the technology assumes that values that occur at opposite ends of the time value scale have opposite financial signs. So I've got present value here as a positive number, which means it's going to produce a future value number here with the opposite symbol, or in other words a negative sign. If I don't want that to occur, what I could do is put a minus sign in front of present value. I'll do that here in the input cell. So I'll come back here, and where it says E2, I'm going to put a minus sign right in front of it. What that's going to do is give us an answer that has a positive sign on it. Okay? So here is our future value of $121 that we calculated using the future value function. And for your review, these are the variables that we put into each of those input fields. So let's have you try a couple of these. You're welcome to pause the presentation at any time. I would suggest that you pull up a spreadsheet and attempt to solve what is the future value of this problem. We have a present value of $10,000 earning 11% interest, which is compounded once a year for 10 years. Go ahead and plug that in and see if you get it. The answer, of course, is here on the slide. Here's another one that you can try just to see if you can do it correctly. Present value of $5,000, so we're going to invest $5,000 for 30 years at 12% annual interest. What is the future value? The correct answer is located here at the bottom of the screen. One thing to be careful of if you are using a calculator is to make certain that, first of all, make certain that you clear the calculator's memory, that there's nothing left. And then make sure that you know how to enter the rates of interest. Also, if you're using, I say calculator here, but if you're using Excel, make sure you know how to enter interest rates. We would generally enter them as a decimal. Some calculators allow you to enter interest rates as whole numbers. And so you need to make sure that you understand the correct entry protocol for whatever technology you're using.